Hi guys, it's me Deepak, and in this video we're gonna build a neural network from scratch. Right now it's being trained. What we're gonna do is, first of all, we need a data set, and for that particular reason I don't have like a data set or something like that. For that particular reason I just have to use TensorFlow just for once for datasets, and I'm using fashion mnist dataset for this particular video. Have to have a data set, so I'll be using TensorFlow. And if you don't have a TensorFlow, then you can just use like pip install TensorFlow, and I think it is about 200 megabytes thing. So yeah, you have to have and I think it will take like a minute or two if you don't have it on your system already. Otherwise you don't need it. Then what we have to do is, once you have TensorFlow, you have to import it in your system. So I'm just gonna import TensorFlow as TF. I mean, think about someone importing TensorFlow as NumPy or something else. The confusion that is gonna cause. So I already have TensorFlow, so it's next thing, our data set. So for that we can divide our dataset into training and testing sets. So what I can do is extrain. So I think it has like 10,000 or something. We're gonna split like 6,000 and 4,000. So we're gonna train like xtrain, ytrain. Y xtrain is images of the data, and y is the labels. Labels are in a numerical form. So xtrain, ytrain, comma x test, comma y test. Then we have to load a dataset. So tf dot curious dot datasets dot fashion. You have to be a little bit of like sure that you're not making any typos here, otherwise it's not going to run. And once we have loaded it, we have to normalize it as well. So the maximum pixel value each each image can hold will be like 255. So we're going to divide it by 255. So the pixel value will range from 0 to 1, and it's very helpful when training, because then weights have to do less work. So it generally gives you greater accuracy. So what we can do is xtrain xtest is equal to, I mean, I have talked about this a lot in my previous videos, but like I think I should just explain this as well. So xtest divided by 255.55.0. So we have loaded our data sets, and now I would like you to just like run it. So I'm in a folder called neural network. So I will just go there and run the code. My file name is neural or something. It's neural, and it will take like a minute or to download the data set. And once you download it, it's not going to download again, so it's just a one-time thing. So it will be preferable if you just like run it now and then now code for the other things as well in the meantime as it download it, because it saves time. Now next thing is to create our neural network. So first of all, let's talk about how you can initialize let's talk about how to create a neural network. I know this is a bit weird, but for that you have to create a neural network. I know genius is what the word you're coming to your mind, like, yeah, obviously, but what I mean by creating a network is by initializing the neural network, initializing the parameters. So first of all, we need to have a 784x1 layer of activation values. I can use this by using a flatten function, as you use in TensorFlow, but in this case we don't have that particular privilege. You have to reshape it. So first of all, That's going to be in the feed for propagation thing. We need to initialize it. So we will initialize a layer with a numpy array of, like, we can use like numpy zeros or numpy ones, 70 crossover one. Then we have to initialize the weights. Weights has to be random. Weight can be random, and they have to have a dimensions of second layer as their x as their number of rows, and columns they should have as the shape of, as the x dot a dot shape 0 of the previous layer. So a dot shape, I wasn't able to draw it pretty well. I don't think you can see it, but weight should have like the dimensions of a dot 0, like how should I say this? So you should have like the dimensions of this second layer x dot shape 0, and the dimension and x dot shape previous layer dot shape 0. So rows of this and rows of this as the dimensions of the weight of this layer, and the weight of this layer has to be the dimension of this cross this. Okay, so this is how you're gonna initialize your data set. Weight has to be initialized randomly, and you have to choose like a very random value. And what you can do is multiply when you initialize it, and multiply it with a small number like 0.01. That's gonna be perfect. If you can just use a very small value work, or should I say like initialize our neural network, because when I say initialize, I mean just creating the layers, random weights, because we have to adjust the weights later. So let's create a class. Let's say neural network, and what we have to pass here, not much, just the architecture. Architecture is like how many number of how should I say this, dimension of our neural network architecture. So I have like a 28 cross 28 image. First layer should have 784 rows and 1 column. So I will have like 784 by 1 a naught value. Second layer should have a dense layer of 128. I'm just going to like mimic what we used in the TensorFlow one. So I'm just basically doing what they have done, but from scratch. So I'm going to write the whole code. So we have to reshape it from 20 to 28. So I'm going to use NumPy. Oh, it's a good thing I should import. Hey, what have I done? What have I done? No wonder it's not going to work. No wonder it's not going to work. What have I done? Should I re-record it? Let's leave it. Okay, what is the error? Line 7. What line 7? There is no line 7. Oh, okay. Let me just comment this out for now. I mean, we have to download it, so okay. We have to import NumPy. NumPy as np. Okay. NumPy, we're using NumPy. I can reshape the array, calling it numpy.reshape, then putting our 28 image and reshaping it to 784 cross 1. So that's going to be a first flatten layer function. So that means I have to initialize a naught values to a numpy one of 784. So what I can do is I can just pass in the architecture. So I need 784 in one, 128 in another, and 10 in the last one. So I'll be doing one hot encoding. I think I should just explain as I go, otherwise it's going to create confusion. So what I need is to pass in the construction. I can just pass like self and architecture. Okay, and what I can do is self.l. I mean, I have seen a really nice article on, I think, medium.com, and that explain this way of setting the architecture. I can just hard code it as well. Like I know what layers I want, so as I'm doing it from scratch, I can hard code it, but also I can do it in this manner. Although to be honest, I really want to just hard code it right now. So I want self.l to hold the size, so you can just call it -1 because it starts from 0, right? So 0 1 2, so if I have 3 layers, it should hold the number 2. I mean, I shouldn't explain this thing, like you should know it. I'm sounding like my professor. He always says like, hey, you should know this thing, hey, you should know this thing. Then why are you here? Derivative. So I need two dictionaries, parameter and derivatives. And why do I need derivatives is for backpropagation, and that will come later. But for now, I have to just initialize my whole layer. So that's why I created this parameter. And what I can do is, first of all, first layer is not going to have any weights. So weights are basically connection between like first, second, third, fourth. So first layer is not going to have any weights. It's just going to have the input layer, input values, like that 784 cross 1. So I'm just going to give it like it's going to initialize the a0 value. So here I have to initialize biases, weights, a0, and that's it. And z values. Z values are basically like you multiply weights and the activation values of the previous layer and add the bias. Then talk about z. Z is like I hope you can see this value. Z is w weights into activation layer of previous value l-1. So what you can have is z is like w a previous layer, because we will be calculating the activation value of this layer through z, plus the biases. Biases again has to be the dimensions of the activation layer row comma 1. So column like this. Okay. So here I just want to see if I have like, okay, so I think it is now downloaded. It's not giving me an error right now, so I think it is downloaded. And now I need to initialize my architecture. So what I need is, for L in range 1 comma self dot L plus 1, and here I have to initialize a values. So I can just write should I say this, self dot parameters a plus str l equal numpy dot ones, and I'm going to have the dimensions of the architecture that I'm applying it. So arc comma I comma L, sorry, and 1. So like the arc1 value is going to hold 128, arc2 value is going to hold like 10, and arc0 is holding 784. I'm going to supply it when I call the object. Hey, first of all, let me just like also just have a0 as well. That is going to be the input layer, and what I'm going to do is np.ones arc0 comma 1. Okay, next thing I want to do is initialize the weight. So I have to initialize them to a random value, and I'm going to multiply it by 0.01 so I can have like small weights. So let's say like w weight for w for weights and strl. Then I want is numpy dot random dot come on random and right, yes, it is arc. So the dimension of the weights is going to be like since I'm multiplying it to the layer previous layer that has dimension arc n minus 1, so it's going to have dimension like arc n into arc minus 1. So if you know a little bit about matrix multiplication, you know what dimension weight should hold. So it's going to hold dimension like arc I comma arc I minus 1, and don't worry, we're not going to get into any sort of like list out of bounds, something like that, because I is starting from 1 and the least value I is holding is 1, so 1 minus 1 0 and arc 0 is a thing. So I mean I usually get paranoid when I'm using like subtracting I from something or adding it to something, because I don't want to get into the whole mess of what do you say, how you say it. Let's leave it. So next thing I need is z, and z holds the dimensions as that of a, because we're not like changing that much when we are just multiplying it with sigmoid or tangent tan h or something like that function. So it's not like we're changing the dimension, so it holds the same dimension as that of our activation layer. So we can do is arc l comma 1, and the last thing that we need is to initialize the biases. So I've got parameter bias plus strl, and with that we are done with initializing or initializing our neural network. Is that right? Yep, it is. Anything else that I missed here? No, nothing. Okay. So yeah, this is how you initialize a neural network. I think I should just comment it like something like initializing our neural network. Okay, so this is initializing. Second step about creating a neural network is feed forward propagation. So we're going to multiply our activation layer with our weights, add them the biases, apply the activation function, get the activation layer of that particular layer, then multiply it with the weights, okay, and at the end of that we're gonna compute the cost. So that means I'm not even like so I haven't done anything with computing the cost in this particular video. I'm not going to do that, but so at the end of it we can like compare what we are getting to compute the accuracy of it. Before let me just show you how it is done. I think then you will get a better idea of what feed propagation actually is. So let me just create a then comes second process. Second process is called feed forward propagation, where we will be multiplying the initial value with weights of this layer and add the bias. Then we're going to take that, then we will calculate this then we will get this activation layer. But how? We'll need a activation function as well. So for in this case I'm using activation function called ReLU. So what is a ReLU function? ReLU function takes input like if you give it an input 1, it will give you input 1. If you give it an input minus 1, it will give you output 0. So what you can see it like if I have to explain it, set the camera, adjust the camera a bit. So you can have a graph like so for positive value of x you can get positive values of y, and for the negative values you can get like something like this. So mostly like you will get something like this. So this is what you will go with the ReLU function. Then you get this activation layer. When you get this activation layer, you multiply it with these weights and add the biases. You get Z. Then you apply a softmax function. Okay, you apply softmax function on the Z that you get after multiplying this A with the weights, add the bias, and you get the softmax function. Then you apply on softmax function. Softmax function just take the exponential of every single Z value divided by the sum of exponential and return it. So this gives you a value, small value in between, I think 0 and 1. This gives you a range in the value, and this makes the job of neural networks easy. And it's especially helpful when you are using something like a multi-classification problem or any kind of classification problem. The softmax is used. Basically, when you use sparse categorical cross entropy function, then also softmax function is used. Although you don't specifically use like you don't give like 10 commas activation softmax like you usually do, because you set logits true. In this case, we don't have such privilege, so we have to do everything from scratch. Feed forward propagation. Okay, it's going to need a self and input value, so I'm going to just call it x. Yep. Okay, so first layer that we're gonna have is a flatten layer. So yeah, I'm gonna hard code every layer. So the first layer that we need is a flatten layer, and what I can do is I can use numpy. That's why I've imported this, so I can just use this x is equal to and numpy dot reshape x and have a dimension of 74 1, and then I can have self dot parameter a0. So this is going to be our input layer after applying a flatten function. Like if you remember the fashion mnist code you have seen on the TensorFlow side, this is the way that we usually do it. Also, there is one thing, if I'm at the end of the video, I'm going to use like live camera feed to take the video, and although it's not working very fine right now, but it is in RGB and I'm turning it on grayscale, so I have to convert the live feed to first grayscale, so I have to reduce the size as well, because it is a 640 320 something like that, and it is 2028, so that too have to do it. Even it look really bad, I mean the image look really bad. Self parameter z1. So our first layer, our first z1 value is going to be numpy dot add, come on, numpy dot add, numpy dot. So we're going to multiply our weight, so self dot parameters. I don't know why all those mails are coming right now. Self dot parameters, so we have weights, weight 1 comma, and we're going to multiply it with the flat array of the images that is 74 cross 1. So I'm going to have like self dot parameter a0, and we're gonna then add it to our bias, self dot parameter b0. Okay, b1, sorry. So this is gonna give us our first layer, and let's call, I think we should just comment it something like dense layer, and I'm going to apply a ReLU activation function here. So if you don't know, ReLU just takes like the value that you're giving it, and if it's above 0, it will give you y is equal to x, otherwise it will give y is equal to 0, so it will remove all the negative values if I have any. So what I'll do is apply a ReLU function here on my activation value. So self dot parameter a1, and I can say is equal to numpy, not numpy, I have to have a ReLU function here. I have to create first, so self dot parameter z1 looks fine to me. Now let's create a ReLU function. Although I do have to also create a ReLU prime. So I'm giving it an x here, and I'm just gonna return. Let me just see what I have done. Okay. Okay, so what I'm doing is x equal 0, x less than 0 equals 0, and then return x. Initially I was going with sigmoid, but ReLU works fine. So what it does is, if any value is holding a value less than 0, I'm just going to make that replace that value with 0. So negative are going to be 0, then everything else will be same in my particular numpy array. Okay, so second layer is also done. Third layer is going to be a dense, and it's going to have a softmax, right? Let me just see it. I'm going with softmax, so dense and softmax. Also I'm using multivariate I'm going to use multi-label classification. So that's why if you have seen sparse critical cross entropy, they don't use a softmax function, because they have set it automatically does softmax. If I turn it for, then I have to add softmax also. So I don't have the privilege of sparse critical cross entropy loss, so I have to do it manually. Is that too? Numpy dot add. To be honest, I feel like I should just copy it. It's gonna save time. I just have to replace 1 and 2. So yeah, there's gonna be 2 here. There's gonna be one here, and there's gonna be 2 here. Then I have to create a self dot parameter a2, and then I have to create a softmax function as well now, and there I will be passing our self dot parameter z2, and let's create a def softmax, and let's pass x here, and let's see how it works. Okay, so what it does is it takes the exponential value of all the input, so if I give it an array, suppose I have an array of 1 2 3 4 5, it was the exponential value of 1 2 3 4 5, put it in the numpy array, so exponential value 1 2 3 4 5, and then I'm gonna divide it by the mean. So that's what we're also I'll be subtracting it from the maximum value of the array. So what I have to do is exp. If you don't know how it works, to be honest, I'm actually going to explain everything on board as well in the video, in the final video that you're going to see, so I don't have to do much explaining right now, that's why. So what I will do is numpy dot exp x minus x dot max, and I'm just gonna return exps dot sum. So if you see it like I should explain, I mean I will just explain it on the board. There's no point in explaining it verbally. I mean you cannot understand anything verbally. I'm saying it from experience. Okay, so I have the this propagation set. The next thing I need is to okay, so what if you want to compute the cost? Okay, that is one thing that I'm not prepared for, so don't ask me how to compute cost. I mean you can just compute cost using something like I mean okay, let's I mean I haven't tried this function yet. I mean I had to try it, but I mean it should be something like, I mean I've seen an article about computing cost, and they said like you should have y into the log of the activation value, and y should be 1 if it is actually the class that you're computing. So for input cases, for test training cases, you know what y is, so you give that y. So if y is, so what you're going to do is, if you have the same y, if you so you have like a whole array, and you're computing it for the last index value. So like I have a, at the end of it I have like a 10 cross 1 matrix, and I know 0 1 2 3 4 5 6 7 8 9. So my labeling is also in numeral form, 0 1 2 3 4 5 6 7 8 9. And what I'm going to do is, if it's 9, that means it is the ninth so let's say if I had like 9 is what is it is a 9 is, I think, sandals or sneakers, something like that, or I think it's shirt. Let's suppose it was a shirt, and it is a and the ninth value is the probability of it being 9 after I have done the whole propagation is 0.2. So I'm just going to multiply y is going to be like 1 into 0.2. So the probability of it being y is just 0.2. I'm not going to like divide it proportionally about. I haven't thought this through what I'm saying right now, but it's something like that. That's why I'm not like computing the cost. I haven't thought this. I don't know how to compute cost right now. It was something about it was like y into numpy dot log self dot parameter a2. It was something like this for multi-label classification problems. For single it was even worse. It was a big formula, 1 minus y into, I mean it was for two binary classification problems. So if y is 1, then one part of equation gets 0, second part of equation works. If not, then second part of equation works. So it was like that. For multivariate, what you can do is create a numpy array of like numpy zeros. Like suppose if you have like a t-shirt is a 0, I know that. So what you're gonna have is a numpy array of every single of 10, and from 1 to 9 is gonna hold 0, and the 0th position is gonna hold 1. So it's something like one hot encoding, and then you can multiply it. Oh yeah, you can just, okay, it's gonna work like that. So I'm gonna have a numpy array of like 10 values, and for like first, second, or third, whatever y that I have, is going to multiply it with the log of that, and it's going to compute the cost. So it's going to work. I haven't tried it, so I'm not going to like put it in the video or something, but you can take it as your own little task if I'm making any sense right now. But yeah, it's going to be like that, something like that I haven't done. But next step is back-propagation. Yeah, I know. My then comes the third part. This is called the back-propagation. So we will use a cost function. So in our case, the cost function is a cross entropy. So y log activation value of this layer that we calculate after applying the softmax. So we will be using dc upon dz to calculate. So what is our plan? Our ultimate goal is to get a good value of is to get the values of weights and biases such that we can have accurate predictions, right? We do first we have initialized random values to the weights and one value. So we are just getting a numpy array of 1 like this, right? I don't think you can see this, right? This, okay. But this is not our goal. Our goal is to get an accurate value. How we can do is we can have weights multiply by dc upon dw, something like something like this, with a learning rate. Learning rate has to be a very small value. In our case, I'm using like this value. Our learning rate has to be small, not too abrupt, or also I was initially going with mean square error, but then it created a lot of problem. So let's talk about this thing. So we have like dc. So first of all, we calculate derivative of cos with respect to z. If we derive this equation, we get a value of y minus, not sigma, the activation value 2. Okay, this is what we get, y minus a2. But after this one, we have to calculate with respect to, because the ultimate goal is to calculate value with respect to dc and dw. Okay, and we know that dc over dz into dz over dw will give us the same thing. And we know dz, and we know z is basically w a l minus 1 plus b. If we take the derivative with respect to weights, we will get dc by dz into a activation layer, or activation value, activation output of the previous layer. That was the word I was looking for, activation value of the previous layer. So we'll get something like al minus 1. Similarly, if we take with respect to bias, divide bias, we get here 1, and weights and a will get value 0. So we will get bias value same as dc by dz. So we get dc by so initially we are calculating with respect to differentiation with respect to this activation layer. We need to calculate with respect to this layer as well. So for that, we will calculate dc by dz with a different approach. We will get dc by dz by calculating dc over zl plus 1, z of this layer. That we dc by dzl plus 1 we have already calculated, and we have got the value like y minus al, a activation 2, right? We got that particular value. Then we get dzl plus 1. Let me just clean it, and I think then you can particularly understand it better. So what we can do is we can have dc over dz. We have to calculate for second layer this time, right? What we can do is dc over dz l plus 1. So for this layer that we have already calculated, dz l plus 1 dA. Why? Because zl plus 1 is basically w al minus 1. So this can also be represented as this thing. So al minus 1, if you put l minus 1 is equal to I, then L is basically I plus 1. So if you can see it that way also, so this makes a lot of sense. And then dA over dz. Okay, what we know about dA upon daz, that dA is basically an activation function into z. So we are basically taking a derivative of that activation function. So here we have the activation function of ReLU. So we will have a ReLU prime function here. ReLU prime just takes For positive values it will give you an output of 1. For negative values, for like negative values it will give you for negative values it will give you a -1. Okay, and dzl plus da is basically the weights of the next layer, l plus 1 layer, that we already know. We know l plus 1, we know dc by z plus 1 by calculated y minus a2, and a ReLU prime function we can easily calculate as well for the z value of this layer, not this layer. Okay, this can easily be calculated, and we will get the dc upon dz, and from that we can easily get dc by dz. We will just multiply it with al minus 1, and we will get dc by dw, and we already know dc by dz is basically dc by db. And then we can change the value of w1, w2, a1, a2 by subtracting them with learning rate minus da1 upon daw and daw upon da1. So with a little bit of maths we can easily calculate everything that we want. I know it's a bit scrambled and all, but I don't have like a camera setup or anything like that, so this is what we have to do with it. And I think camera is on. I think it has been trained fully, so let's see how it's doing, and hope it is doing fine. After completing the pre-propagation, what you have to do is go back step by step. So first of all, to like I hope I had like drawn the network or something, but first you will go to the third layer, then second, then first. So you have to compute how bad your result was, something like that. And for that, let's create first of all a function called back-propagation. Back-propagation. I'm gonna have self y and a learning rate. Learning rate is something that I struggle with a lot, but what I found out is this hold best for me. I mean, I get an accuracy of 97%. Like this time I have results as like in my previous snake game video where I was using what I was using. It's just like a genetic algorithm. I didn't have results, but this time I have. I mean, you can follow me on Instagram where I post what I am doing next. Self dot parameter. I think this time what I can do is so if you take the derivative, what I do is to take the derivative of cost function with respect to w and b, multiply with the learning rate and subtract it from the value that we have. So earlier I was using mean square error, and I was getting stuck in some sort of like a local. I mean, if you have known about mean square error, you can get stuck in some sort of a local solution. Like I'm not like remembering the word that you use right now, but you get stuck somewhere. And I was stuck in at the accuracy of 70%. Even if I turn like 200 times, that is overfitting, I know, but you will get an accuracy of 70% best, and it's not worth it because it's not then. But here, after using this particular function, I get an accuracy of like 97% in 5 epochs. First epoch I got an accuracy of 94%. It's pretty good. So what I have to do is calculate the derivative for the third layer first, the second layer, then first layer. So we're going backwards from the last layer to the first layer. And that was the phrasing that I was looking for. From the last layer to the first layer, we're gonna go back. So I have like this derivative, right? I created a dictionary, so I can have like dz. So first I'm gonna compute the values for dz. So cost is compute using our activation layer, as you can see here. So I'm using like this cost function right now, although I am I wasn't sure if this can actually work. Hey, what was I saying when I was saying I didn't know about the cost function? I know it is. I mean, when I was saying like the cost function don't work as you say. I mean, what I have done, what I didn't actually calculate the cost. initially, so if you don't know, actually I've just read, like, yesterday I finished the project, and I'm still like 90% sure I get what I've done. So I think I misinterpreted something. Like, this is how you're gonna do it. What I was trying to say initially was I haven't calculated cost in my whole code, but this is for sure gonna compute the cost. And what you can actually do is self dot parameter, like, put it in a dictionary as well, so you can compute the cost and call it from any function that you want. So this way it's gonna work, so you can actually do it. Okay, this is gonna actually work. Okay. So what I will tell you is we have like y into numpy.log. The cost function is dependent on activation value, and activation function, our activation layer, is dependent on z, because we are using a ReLU function on z. So if we are taking a derivative of cost with respect to z, that means we have to first take a derivative of y with respect to a cost with respect to activation, and then activation with respect to z values. So if we solve everything, we will get something like self dot parameter a2. I mean, I'm gonna explain the whole derivation on the board, but still I have to like edit a lot of it. Let's load this video right now. This is turning really bad. Next thing, I'm going to take a derivative of dw, I mean with respect to weights. So weights are dependent on z value. So if you take that derivative of cost with respect to weights, you're going to get something like a dot product of the z value and the transpose of the previous activation layer. Yeah, because you have like w1 into a, right? So if you take the value, you're gonna get something like that. I mean, trust me, I mean, that's just how it works. So what you have to do is okay, let's code it. So sub dot derivative dw2 dz2, this should be equal numpy dot self dot derivative dz2 comma numpy dot transpose, yeah, numpy dot transpose self dot parameter a1. Yep, this is what we're going to do. And if we calculate with respect to bias, so bias, so if you see like z is like tw, z is like w into previous activation layer plus bias. So if you take a derivative with respect to bias, it's going to give you 1. So 1 into second derivative of dz2. So it's basically same as derivative dz2 value. So dot parameter dot derivative of dz value. So what I can do is self dot derivative dz2 dv2 is equal to numpy dot is equal to self dot derivative dz2, and the next set of derivative values are also pretty same. So for the dz1 values also, only change is how you calculate dz1. So initially we were calculating with respect to the cost function, but now we will be calculating with respect to the next, like we are on the second layer, we will calculate with respect to the third layer that we got. So based on the third layer, we're going to change the value of that. So with unlike cost function, here we're going to see for dzl plus 1. So for that, what we have to do is So if I'm gonna solve it on the board. So if I have to calculate it, I can use it like d z1 is equal to numpy dot numpy dot transpose self dot parameter w2, so weights of the w2, comma self dot derivative dot dz2, self dot derivative dz2, and we're going to multiply it by this should be here. Okay, and we're going to multiply it by a ReLU prime function, because we will also be taking the derivative of ReLU prime. So I have to create a ReLU prime function first, and ReLU prime just takes like if y has like positive value, x has positive value, y will be 1, otherwise it will be 0. So it's it actually gives you like 0 1 value. Okay, now let's create a ReLU prime function, otherwise I'm going to forget about it. So what I need is, although it's like a good practice if you just copy paste what you have written earlier. So what I can do is return numpy dot where x greater than 0 comma 1.0 comma 0. Let's make 1 here. Okay, so if it's greater than 0 then 1, otherwise it's 0. So this is pretty much a ReLU prime function. So nothing like like weirdly tough or something. Next thing we're gonna calculate is dw1 and dw2. They're pretty much the same thing as this one, so you can just copy paste it. Also you have to change the value. So dz1 and this should be a0. Okay, not much. Now we have to do is upgrade the value, and this is where learning is very important. So let's have like upgrade value here. So what we can have is self dot parameter w1 self dot parameter w1 minus alpha into self dot derivative dw1 self dot parameters b1 self dot parameter b1 minus alpha into self dot derivative db1. Okay, is it right? Or oh, okay, I made a mistake here. It should be minus here. Let me just check few things here. Yep. So this is gonna get the value of first layer, and similarly I'm just gonna create a value of second layer as well. So I can just copy paste it to save some time. And the only thing I have to change is change 1 with 2. Yep, that's the only thing. And with that we are basically done, when you believe it, 43 minutes, and we have almost data set or neural network. Next thing we have to do is create a function, def predict. This is I'm gonna call whenever I have to check the accuracy if what I am predicting is right or wrong. Don't worry, this doesn't do anything fancy. This just calculate. This just call this function. We have to pass value x here and return self dot parameter a2. Yeah, this is what this function is. It does nothing. It just return the last layer, and then I'm gonna compute it with the I'm just gonna compute what is the what index hold the maximum value, and if that maximum value is if that maximum value index is the same as the index of y that hold 1, then that means my accuracy is correct and it's giving me what I want. That's how I'm going to train my neural network. That is how I'm going to compute the accuracy. Okay, let's call a fit function. You must have seen this in TensorFlow as well. So I am following the same neural naming convention here. I don't know what's wrong with the board. Self comma x comma y comma num iteration. Okay, so here we are. So what I need is for iteration in I haven't created a for loop yet, right? That's why I don't give me an option here. For iteration range num iteration, what I want to do is have an accuracy is equal to 0 for I in range x dot shape 0 y array is equal to numpy. I'm going to create a so this is where I'm going to do this one hot encoding like thing, where I'm going to have like a numpy array of whole zeros, and then I'm going to do is I'm also going to have like an if condition here. So what I'm going to have is for j in range 10 if j is equal to, okay, first of all I have to do one thing here. Y is equal to yi, and while I'm here let's just also do this xi. So for j in range, okay, so you may be wondering why I went with j and not I, because I actually made a mistake here. I accidentally write one time, actually put I also here as well. If j is equal to like y, then I'm just gonna put there then what I'm going to do is y array j. So for that particular index I'm going to put 1 there, so otherwise you're going to hold 0. And I actually come across read this article that explain that why you do one hot encoding and not like, so like so you have like 4 colors and you want to do a classification, you can use 2 bits 0 0 0 1 1 0 1 1, but then the weights get activated for a one particular bit twice, and that creates confusion. So that's why you use one hot encoding like things to avoid any confusion. So okay, so this is almost done, and now I just have to do is call of my function from here. So self dot, first of all, feed for propagation, passing my x there, self dot back propagation, passing my y array, and then I will call like my self dot predict function. After I have changes after I have done back propagation, I will have different weights and biases. So then I'm going to again compute the for propagation, get activation value, and then see how good it is. So by self dot predict whatever passing there, right? Then what I would do is convert ypred. Okay, so this is something that I'm not very particularly proud of. I could have done something else, but this is why I went. This is where I went. So I have just created a list here. I will convert it to a normal list, and then what I did was I calculated the maximum value of ypred. So it is an array. So I will just get the maximum value, and then I will get what index it is. What index it is at. So yn and ypred dot index z. Although I could have just done like maxpred also here, but okay, this is working. So okay, so now I'm gonna just do is if y in is equal to y, then accuracy plus equal 1. Okay, and at the end of this for loop, when this for loop end that is there, I'm just going to print accuracy for each epoch. So print accuracy. So what I can have is here like this, ASCC divided by x dot shape 0 multiplied with 100 to get the percentage. Then I want at what number the epochs is, so number, and I can have iter here. This is going to just print the accuracy. Yep. And now I can just call the, first of all I need to create an object. So ann is equal to neural network, pass a numpy dot array here, and the array should have like 784 comma 128 comma 10. After that ann dot fit xtrain ytrain and 5. Yep, that's what, and let's run it. Obviously this is gonna have a lot of like, okay, so soon, what, okay, I mean that much I can accept. So what I'm right current, so after this, after we have created a neural network, now what I want is I want to take a live feed from my webcam and see what value and see and I have to process the image a bit, because like I want to like eliminate my head and all, and I just want to like see the shirt, and I want to see like if we can judge if it's a hoodie or whatever it is. Okay, so I've made a mistake somewhere here. Okay, line 32. Line 32. Okay, there should be L. Obviously this code was gonna have like a lot of errors, or like debugging have to be done now. So I'm like 51 year mark. Okay, so let's while this code train, I will like very much appreciate if you can just like open another file here, save it. So I'm gonna name it like test, because I'm just going to create create code for how to get feed and process it, because I cannot do it here because it's going to run like 5 epochs every time. Before that, and waiting for that much long is going to take hours. But like every time, I mean it's like every time 5 iteration takes like 2 to 3 minutes, and then I have to see if my code works or not. If my code doesn't work, then I can 2 to 3 minute process. So it's better to just have like another file where I can see the code that I'm writing has no bugs. Okay, so it should be in Python. So what, numpy has no attribute 0. First of all I have to do something. rm numpy has no attribute 0. Where what have I done? Okay, it should there is no e there. Line 93. So this is like my fault. Okay, I can now save it. Control N, save. Okay, test dot py. Okay, now I have it right. Now what I want to do is create something that can process my image. So for that I'm actually going to do like HS hue saturation changes in my images as well. So for that I have to create like a track bar like thing. So for that I need like function empty. That's going to do nothing. It takes an argument. I'm going to create like cap is equal to, okay, first of all let me just import cv2. What then I need is import cv2. If you get an error, just like pip install opencv python, something like this is a command that you have to do. I think this is the command that you use to install opencv. Just do that. Then what I have to do is first of all I have to get a live feed from the camera. So cv2 dot video capture. 0 is the ID for a webcam. Then what I need is cv2 dot set cv2 dot named window rs cv2 dot resize w ind or w window, and I'm going to resize this track bars to 640. I mean I learned about this from a YouTube channel, a YouTube video. I will link that video that actually explains how to use OpenCV2 very well. It's like 3-hour video, and I think it's worth giving it a try if you want to learn about OpenCV. I learned it from that, so I will leave the links in the description. And this is like the really nice way to like process the image live. Okay, so I have an error here on line 63. A1 is not defined. What? Oh, okay. Line 63. So let's run it again. I will come to it later. So what I have to do is now create track bar. So cv2 dot create. Be a bit careful with typos, because you can very easily make them and get stuck for like hours trying to figure out what you have done, and you won't figure it out. I mean, it takes a lot of time otherwise if you just like stick to like trying to see what you have done. 179 comma empty, that is a function that we have created. So let's just copy it and paste it 5 more times for hue maximum, saturation minimum, saturation maximum, and minimum maximum. So 5 times you need it. Obviously you have to rename it. So and also, okay, I should min actually. Saturation. Hey, what? Okay, no, it's fine. It should be saturation maximum. Then it should be val minimum. obviously I need one more line here for maximum as well, and I need to change the value also. So Satch and Satch and val can hold maximum of 255. Also the maximum should hold the highest value, like 179 here. 255, 255, 255, 255, 255, right? Right. Okay, this is about creating the bars. Now what I need is a while true loop. Since I'm getting a live feed every single time, I need a thing like this. Okay, while a0 is not right. Okay. Okay. Nothing to worry. This is very normal. This happens a lot of time. Be calm. Don't lose your cool. So since we are getting a live feed from the since I'm getting a live feed from the camera, I like a video footage. So video is like 60 photos per second, like thing. So I'm actually getting like photos at a very rapid pace. So I have to get I'm using a different loop, and every time I get like an image, I'm gonna I'm gonna process it using OpenCV. So let's see how I'm gonna do. So I'm gonna get something like a success. So this is actually a boolean variable and an image. So cap dot read, and what I can have is h minimum cv2 dot get track bar pause HUE. Remember to write the same name as you have written there, as well as mention the track bar. Okay. Then you need to do it 5 more times for all other things as well. So let's okay, so I have changes everything, and now what I'm doing is create 2 tuples, where one tuple is going to hold a lower value, one tuple is going to maximum value. Also I have to change the image to HSV as well before I can actually do some pre-processing. But let me just see if everything is working fine. Oh, what the hell? What accuracy is this? What the actual? What the hell happened? Okay. It should be x dot shape. Okay, my bad. Okay, on this one, my bad. Good. I just want to see the first accuracy, if it worked fine or not. Now I'm actually getting hype. Wonder that someone getting accuracy of 22. Okay, 203,000. Come on. 1 hour into the video. 1 hour. My god, this video is gonna be long. Yeah, come on, yeah. Okay, 95.033% accuracy. Okay, that means this is a success. Okay, this is like lifted a burden off my chest now. Okay, so I can now focus on this thing, right? Okay, so what I need is create two tuples. I need two tuples like lower. One is going to hold like minimum for everything, and one is going to hold maximum. So let's create two tuples like this. Oh, not tuples. I made this mistake last time. Please don't make tuples. Please don't make tuples. I was going to do the same thing. I remember last time I almost like spent like at least I think half an hour trying to debug the code because I made this mistake. You don't have to make the tuple, you have to make numpy arrays here. Numpy arrays. It's good that I'm not making a fun of me on the YouTube right now. Right? Okay. What I'm going to do is mask is equal to cv2 dot in range. I need the cv2 dot cvt color. I have to pass image, and that I'm converting it to cvt dot bgr to hsv. Upper. Then I have to do is image result is equal to 2 dot bitwise and img comma mask equal mask. This is gonna take the changes that I do in my CVT and implement it on the image, and that's it. That's what I have to do. So what I can do right now is the image that I get after processing, I can convert it to grayscale. What I can do is image is equal to, because I cannot process the RGB color image, which will be length 20 cross 20 cross 3. That I don't want. I want 20 cross 28. So cv2 dot cvt color. I have the image result. What I do is cv2 dot color bgr to bgr to grayscale. Okay, and then I have to resize the image as well. So cv2 dot resize image 28 interpolation equals cv2 dot cv2 INTER AR EA. Yep, this is pretty much the code that I want. And what I can actually do is I can actually put some text. Okay, I can actually. So what you want to do is if you go to TensorFlow and fashion mnist, and you can actually see what 0 stands for. So 0 actually stands for t-shirt, 1 stands for trouser, 2 stands for pullover, 3 stands for dress. So what I can actually do is actually I have written the code here already, so I don't have to where's the code? I don't want to write the whole code, man. I don't want to write the whole code. Okay, so accuracy, as you can see, 97.1966%. That is very good. Like that means out of 10, 9.7 times, 9 times I'm actually going to get the one right answer, and that one also I have 70% chances that I'm going to get. So they're like very high chances that I get the right answer. Granted that I have the same, that I'm providing the same image that I have processed on. So like I can't just give my live feed. Like I can just be like there and like see that I'm wearing a hoodie. It cannot judge it like that because my head is there. There are other factor, while the image just had like, what do you say, the clothing, right? Although I can actually process my image to get the head and background and everything and just give it shirt. I mean, I was able to do it. That's what I'm actually trying to do right now, if you haven't noticed. So okay, so what I do is copy this thing. So what I do is I will just go here. First of all, let me just copy this. Second thing, import cv2 here, import cv2. Third thing, first of all, let me just check if the code works or not. Python test.py. Let me see something is wrong here or not. What is wrong? Okay, I have to like I have to have this. Okay, let me see if it works or not right now. Come on, work. Come on, I mean, it should work right now. 1 hour 9 minutes. NumPy is not defined. If it knows that NumPy is not defined, why doesn't it define itself? Yeah, I have also seen the joke. But a new style get arg format, but argument is not a tuple. Okay. Right. It should be like this. Okay, now it's getting the live feed from my screen, and I cannot see it. I can only see. No, I cannot see it. So the issue is I'm not actually printing what I'm getting from the screen. So I have to like print it as well. So I can just do is cv2 dot im show, and I can have like image, and I can have image there. So this is the processed image that I can actually show, and also I can like cv2 dot weight key1. So let's give it 16. So this is going to be like 60 frames per second. So I think okay, now you can actually see myself, and now I can actually, if I change the value, you can see I can pretty much process the image in whatever shape or form I want, and I can actually make no changes. Now last thing I want to do is have if conditions. So let me just break out of this thing, and now let me just copy the code. So let me just copy it, get here, create a def process image, pass self here, and what I need here, just like process image here, I need only self, paste it there. Yep. Now it is okay, working fine. And what to do is, after I have resized it and all, I can do is I can give this image to like ypred is equal to, yeah, you can see the trend what I'm doing right now. Okay, self self dot predict, and I can pass my image now. After passing the image, I have to do this thing. Okay, and whatever index I get, I can put it on screen. So what I can do is also I can just like print y in. That's one thing, but another thing, cool thing would be if I do like if y end is equal to 0, what I can do is cv2 dot put text. I can have the image I am showing, so image comma so rather than showing the actual image, I can just show this thing. I can just show the image that I'm getting. Also I can show the processed image as well. Command C, Command V, and here I can actually show the processed image that I'm actually sending there. And I can just write t-shirt if index is 1, comma 15, comma 15, comma cv2 dot font caps lock eh t hershey. This is the font that I'm using. Complex, I know. Thickness and scaling, so this is the scaling I'm going for. 1. Color is green, and size. Okay. So if y is, and similarly for other like thing, there are 8 more. I have to just copy paste this thing. Okay, let me just quickly do it, like 1 2 3 4 5 6 7 8 9. Okay, that's right. Now to do is USCR trouser. What the hell? Okay, pull over dress. 4 is a coat. Sandal. And SHIRT. Shirt. Sneaker. Bag. Ankle boot. Okay, so this is going to do everything that I have said it, and it's going to process it and everything. And I have, I think, the last thing that I did was create a function called empty. So let's just create an empty function as well. Empty, it does nothing. I have imported cv2, so I think it should now work. Okay, it should now work, but let's see it. Okay, I mean there are some other, I mean while it train I should just let link the resources that I really like. So this one, and this one. So this article really helped me in the whole in the help creating new network. It was about, I think, binary classification or some other thing. This really helped me, and this is where I got the idea, and this is where you can get the labeling as well, everything that you want. The training site, you can see 60,000 labels and all the other stuff. It's in grayscale, whatever. So this is where I got the idea of creating a neural network from like scratch. Come on, yeah. Oh, fish. Fish. One of the biggest enemy betrayal of all times. This we are almost gonna get an accuracy of 97%, 96.99%. What the hell? Okay. Like shit. Yeah, and then dot process image. I didn't even call the function. Okay, so I think the network has been trained now, and let's see. It's telling me I am a bag. Okay, so I think I have to do a little bit of processing. I mean, it cannot like tell like what I exactly look like. So let me see. An ankle boot. If I can expand this thing right. Look like a trouser right now. I don't think it can actually tell from the live feed what I look like. No, I don't think it can. But maybe if I can just like show it a shirt or something, I think it then can. I'm not sure. I can process it like that to get me a live feed or something like that. I was expecting it to like get something like. Let me see if I can just pull it a bit down. Let me see. Okay, now it's telling me I look like a shirt. So it's picking up shirt. How? I don't know. Let me see. How is telling it like a shirt or something? I don't get it. A bag now? I mean a shirt. Okay, I mean I'm not gonna complain anything. I mean, this does sort of look like a shirt, so I mean, it is a pullover. It should tell it is a pullover. Can I do something like that? I mean, I haven't tried this thing yet, so I'm not fully sure. I think it's just saying like this round thing and no, I don't think it can tell. So this was a bit of failure. I was hoping I could do something about it, but I don't think I can. So what can I do? So I think I have to just end the video here right now. So let's hope I see you in my next video. Also, the next video is going to be a bit fun. It's not going to be my usual tutorial videos. So my friend has been roasting me on Discord a lot lately because I didn't know about Discord bots and thing, and they got everything like Dank Memer and all those bots on the Discords. Some of them all created their own bots, and they roasted me a lot there. And I want to take my revenge. And I thought, why not milk it? So I will be coding it in Python, a Discord bot, and I'll be roasting them. And that's going to be like a vlog video that I will be doing. And let's see how it. I will be posting it. I think this video is going to be soon because it doesn't require that much work. I've already built half of the bot already, so I think it's going to take like 2-3 more days to build that bot. Obviously, I'm not working on it as much as because I'm also working on an Unreal game. That's going to be very fun. Like, it's going to be a horror game. Me and Ayush are working on it, and as soon as we have built it, I'll be posting it very soon. So I hope I see you in these 2 videos. Thanks for watching.